Welcome to the lecture series on industrial mathematics. Today I would like to discuss with you one of the important theorem, Fourier inversion theorem. Fourier inversion theorem says that if f is a continuous function on the real line and it is an absolutely integrable function, which means integral minus infinity to infinity mod f of x dx is finite, then script f inverse of script f of x equal to f of x for all x, which means f and f inverse cancel out. Okay, the proof is like, take a continuous function f that is absolutely integrable on the real line. Okay, let capital F denote the Fourier transform of the function small f. Okay, then for any real number t, we can write f inverse, script f inverse of f of t equal to 1 by 2 pi integral minus infinity to infinity f of w e raised to I w t dw, which is the definition of inverse Fourier transform. Okay, then this is equal to, this is the definition of inverse Fourier transform, definition inverse Fourier transform. This is the definition. Okay, this is equal to 1 by 2 pi I integral w equal to minus infinity to infinity. We can replace this f of w because this is the definition for Fourier transform. We already mentioned that capital F denote the Fourier transform. Okay, then we replace capital F of w with the definition. Okay, then this is equal to integral x equal to minus infinity to infinity f of x e raised to minus I w x into the remaining term e raised to I w t dw. Okay, this is the definition, which is equal to 1 by 2 pi integral minus infinity to infinity integral w equal to minus infinity. We just interchange the order of integration, and f of x e raised to I w of t minus x into dw dx. Okay, this is equal to 1 by 2 pi I integral x equal to minus infinity to infinity. We take the function f of x outside of the integral with respect to w, and we write the remaining term integral w equal to minus infinity to infinity e raised to I w of t minus x dw dx. Okay, this is equal to 1 by 2 pi I. Actually, we have used a lemma, we already proved. 1 by 2 pi limit epsilon tends to 0 integral x equal to minus infinity to infinity f of x into root pi by epsilon e raised to minus of x minus t square by 4 epsilon dx. For completeness, I would like to mention the lemma. The lemma says that integral, the lemma says that for real number t and x, integral w equal to minus infinity to infinity e raised to I w of t minus x dw equal to limit epsilon tends to 0 root of pi by epsilon e raised to minus x minus t square for epsilon. Okay, so actually in the proof we replaced this term using the lemma, root pi by epsilon e raised to minus x minus t square for epsilon dx. Okay, next we take an arbitrary variable y equal to x minus t by 2 root epsilon. So after calculation we get x equal to t plus 2 into root epsilon y. After differentiation we get dx equal to 2 root epsilon dy. Then f inverse of f of t, f inverse of f of t becomes 1 by 2 pi limit epsilon tends to 0. Okay, root pi by epsilon, we take outside this term root pi by epsilon, and 2 epsilon, this 2 epsilon comes from the derivative dx term 2 epsilon. The remaining term is y equal to minus infinity to infinity f of, we already mentioned that x equal to t plus t root epsilon. So then becomes f of t plus 2 root epsilon y e raised to minus y square dy. This comes from this term. We already set y equal to x minus t by 2 root epsilon, then it becomes e raised to minus y square. Okay, this is equal to, we know that limit epsilon tends to 0, f of t plus 2 root epsilon y equal to f of t for every y. Then see, we can cancel the terms of epsilon and this epsilon, cancel out, and a 2 from here both sides, and root pi and pi, remaining term is root pi. The balance term is 1 by root pi f of t. F of t comes from this term, f of t into integral y equal to minus infinity to infinity e raised to minus y square dy. We already know the integral value of e raised to minus y square from minus infinity to infinity is root pi. Then this equal to 1 by root pi f of t into root pi. Root pi cancel out, we get f of t. This is the desired result, because finally we get f inverse of f of t equal to f of t. Okay, thank you.